This segment deals with basic road assessment. For many landowners, this may not be a big deal. If you have a small section of road that you've got some issues with, it's pretty easy to identify. I cannibalized somebody else's presentation there was a guy from Oregon State. In the western states, Oregon and Washington, industrial forest landowners actually have to have an inventory of their maintenance needs and actually have to have a plan that they execute. They have to submit to the Department of Natural Resources. And that's probably the premise behind how this program got started. But there's still some value, I think, in it for landowners in Utah. The basic part of the assessment is to identify problems, focus on road repairs. Most of the problems you'll find are water related. You collect the minimum information used to evaluate the road's usability and potential effects on water quality and fish. The objectives, you want to identify poorly performing components of your road, those that need to have some maintenance performed on them, and prevent future damage through prioritized maintenance, basically deciding what's the most bang for the buck or the most urgent priority in solving those problems first. Many of your drainage problems, you need to start kind of at the top and work your way down to fix the problems. Sometimes you just send the problem further downhill. So you kind of need to look at the whole situation, decide where you need to start. The benefit of identifying the problems and then fixing them can be reduced long-term costs, especially if you have some roads that you're doing some surface rocking. If you can keep from losing that off due to erosion, you can save a lot of money. The other is just your normal maintenance of grading your roads and keeping them smooth. The other benefit of fixing your problems is protecting the water quality and fish habitat. The road on the left here is a poorly maintained road. You can see the ditch line's not maintained. It's grown over. It's got organic debris that's sloughed off and fell into it. If on a situation where there's much of a grade, having this grass strip in the middle, it kind of builds up its own organic material with it. And a lot of times you'll end up with the water running down the treads on the road instead of flowing across it. So grass sometimes can help. It can be a filter, but at times it can also cause problems by focusing the water on the road, causing erosion. Over here, you see you have a well-maintained ditch, got a culvert. It looks like it's wet out, but the road looks like it's got a little bit of a crown to it, and it's draining well. Okay, the assessment looks at the road components to determine what's performing well, what's performing poorly, and then looking at the conditions to determine if they prevent or impair the intended use of the road, and then also looking at the environmental impact of it. The procedure basically follows the water. And if you go through this, and our examples when we go out in the field today, you'll see that water basically is what's causing probably 99% of the road maintenance problems that you'll face. You want to know what the water will do during the wet season and what will happen during a flood. These are things you need to take into account when you're looking at assessing your drainage structures and how they're performing. You can see I like the GPS unit. It's pretty easy just to go along your road and make waypoints wherever you have a culvert, wherever you think you need a culvert or a water bar. If you have a place where the water's ponding, all those things, you can just make waypoints and label them. And if you're the landowner, you're doing the assessment, you're also going to be doing the work. Obviously, your documentation doesn't have to be too extensive. But if the person that's doing the marking is not the person that's going to be doing the maintenance, you need to hang flags right on them, leave notes so that the person that comes in with the grader or the backhoe or whatever that's going to be doing the work can identify the exact sites where you want culverts installed. Once again, I use a clinometer, basically for shooting grades, looking at gradients for pipes or stream beds. Measuring tape, so if you're going to be putting in culverts, A lot of times they may be skewed across the road. You may have different length pipes, so you need a tape measure so you can get a handle on your pipe requirements. So when you order them, you can order them all at once. Flagging, mark the locations on the ground. If there's brush to hang it on, you can just label a piece of flagging, like Lou has here. Just write on it, hang it on some brush. If there's nothing there to hang it on, have some lath stake that you can label. This is an example on Red Creek Road. Basically used the GPS unit and actually made the labels on the GPS unit after going up the road. Starting here, in this particular case, there was a 12-inch culvert that wasn't functioning very well, and the call was to replace it with a 24 by 40. And just above it, the berm was trapping the water on the road, not allowing it off, and it just needed a ditch out or a blowout, a place to knock a hole in the berm so the water can leave the road. Just more culvert calls and ditch outs going up, and then calling to reestablish the crown of the road between this point and that point. I don't know if we haven't talked about that much yet, but the tendency is on roads to just blade them flat instead of put a little bit of a crown in them. And a lot of times this is why you get a lot of the ponds and stuff in the roads here, is the water doesn't flow off of them. It doesn't take a whole lot of crown to move the water, but it's something that's important to establish and maintain in your roads. The second example here is a second situation where went along and just made the waypoints and then had my field book. Anyway, this would be the field notes. I happened to type these. I gave them to another person for a document. But with each of the point, with each waypoint, just described what I wanted there. Water bar. In this case, it was ATVs had made a bunch of trails. This one would get muddy, and so you got one over here, and then you got one over here, and pretty quick you had 10 of them wide. And to discourage that, we wanted to go in there and basically put a tank trap or a trench across each end of it, and then put a log worm fence or something on there so they wouldn't drive into the tank trap, and try to get that healed up. And so these were just descriptions along there. You have the waypoints, you have a file, you can keep that. The maintenance may not be done this year or next year, but then you have a document that you can give to a contractor, and they can go out a couple years from now and should be able to find these locations. Drainage structures. Assessing, we talked a little bit about water bars, and Lou showed some examples, and he did mention about the clean out part. And the other part of it is when people put them in, they generally get the berm, but a lot of times they don't actually get it cut down into the subgrade. And it's pretty easy for that berm material to get knocked out of there. But if you actually notch it down into the subgrade, into the native ground a little bit, they tend to stay in a lot better. This one's a little out of focus, it looks like. This is a water bar across the road that obviously is a road closing type water bar. It's not a drive-through. This is on a skid trail. It looks like it is down into the native soil a little bit here, and it looks like it's open. It's angled a little bit and open at the bottom, so it will drain out. The biggest mistake on water bars is people come in and make a knot straight across and basically build little ponds, one above the other. And so instead of taking the water off the trail, they do slow the velocity up, trap a little bit of sediment, but they don't actually get rid of it. So you need to actually make sure you put enough of an angle to kick it off the trail or road. Another example of a water bar with the berm, and once again you can see that it's drained out. Okay, the trench cut, I call them ditch outs. Some people call them blowouts, but where your ditch comes to a point and you want to relieve the ditch water off the road, they usually cut a notch and just basically have a ditch that continues on and disperses the water. One thing you want to be careful with on these is if you've got a road coming down, say a 10% grade, the temptation is once you get off the road to cut these down the hill pretty steep, and you accelerate the velocity, and what you do is you end up with a pretty severe cutting right where it dumps off. So it's important to maintain your ditch outs at a fairly low gradient until it takes it far enough to disperse the water. And here's an example of a plug culvert and a washout. And if you're assessing your road needs, it'd be pretty obvious that you had to do something about that one. And the best way to inspect culverts generally is to look inside of them. If you have an assistant, usually have them do that. I think it was one of Garland's slides, wasn't it? I'm not sure where that came from. It might have even been manufactured. Maybe it wasn't even real. Filtering. This is a problem. We'll actually see this today, where you have ditch water coming down and dumping right into a stream. And there's several problems with this. Many times you'll see an example today where it's coming down, dumping into the inlet, and one of the pipes we'll see today is actually fairly well filled in, and it's not from material coming down the stream itself. It's actually from material coming down the ditch line. This is way too much water to carry in a ditch. There should be cross drains carrying the water off further up the road. This a diagram kind of showing what a person would like to see. Ditch water coming down the road, having a ditch relief culvert kicking it across, plenty of distance between the outlet and the stream so you can get filtering. Got some rocks, maybe some road construction debris you can put down here to disperse and reduce the energy of the water so you don't end up with getting some cutting action down here. Talked about rolling dips before. This is a situation where it's armored and water can come down the ditch line and cross the road in here. Mainly it's getting your ditch water out of the ditches and not directly dumping them into the streams. When you're assessing the drainage structure condition, if it's a big project and you want to have a long-term record of it, you can come up with codes for the different conditions. To make it easy, you can have your own little chart for in-house work. It could be a document you give to a contractor to do the work. And depending on how many types of structures and what have you, you may have a lot of codes. It depends on how fine you want to break it down. And in the case if you're using GPS waypoints to mark culverts, if you've got one that's in perfect condition, you may just mark it as a culvert and then have no more comments on it. Just looking at the different statuses, if the structure's in good shape, if it's collapsing, if it's bypassed to the point where water is going around it or over the road. Water backs up. You'll see this if it's undersized sometimes. It'll handle normal flow. If you get a heavy event, it'll pond up and then it may go over the road or it may just raise the level and then drop back down again once the storm event's over. And then whether the structure is plugged by mud or debris. 10%, kind of a random number, but if it's plugged more than that, you may want to do some maintenance to try to unplug it. If anyone's ever cleaned culverts before, it's not very fun. Okay, one of the things on older pipes, most of the newer ones are galvanized and they last pretty well, but you'll see some of the older steel ones that are rusted. Some are rusted really severely. Mechanical damage, the most common, is done by graders. I don't think there's any grader operators back there, right? We used to call the culvert ends grader targets. They tend to get crimped a lot. And then the other thing is looking at is whether a gully has been formed, which means you probably have too much energy at the pipe. And significant erosion of the soil, once again, it probably means that you have an energy dissipation problem. Pipe on the left, obviously not functioning very well, it's rusted out. The one on the right, that probably wasn't a grader. It looks like something probably ran over that one, or rock came down off the bank and smashed it. That would be a greater problem right there. This one here, the pipe was too short. Looks like a fairly new installation, and they're just putting the road fill over the top of it. You can see that the pipe wasn't of adequate length, and they're starting to fill their own pipe up. The other thing to assess is the drop. If you have a fish-bearing stream, most people like to keep the plunge at 6 inches or under for small fish. This one here, I'm not sure the exact size of the pipe, but you can see from the outflow, it doesn't look like there's any erosion much here. So whatever energy, that height there, it's not cutting. So if it's not a fish issue, it's not a maintenance issue. This one here, all same thing. It's got a few rocks placed in here to help dissipate so it doesn't cut in the plunge pool there. Looks like it's functioning really well. This one's not functioning quite as well. We refer to these as shotgun pipes. You can see there's a pretty good plunge here. It's eroding. You can see mud. It looks like it's got a rock here. If they armored this, it might help, but that's too high of a plunge, too much energy hitting the ground. It's definitely causing erosion.
What do you do?
On those, you could, when we get further in there, you can use downspouts on them. You can armor them, put some rocks and some root wads down there, and give it something to kick off of. Basically, you want to dissipate the energy. Downspouts are a pretty easy method. You use a downspout long enough to get it off the toe of the fill, get it down to native soil. This looks like it was a cross-drain pipe. Probably, I mean, it's a pretty good sized failure with that one. This one here might have been a stream since there's water coming out of it. It's failed. It looks like, I'm sure with their shoulder right here, the pipe was too short. You have a long fill slope here that was dumping water onto. It saturated it, eroded it. Same situation here. The pipe, many times, if they don't put a downspout on it, this is a case where they might have pushed a fill across this stream and then they notched in for their pipe instead of laying the pipe, down at the actual stream level and then putting the fill over it. But there's way too much energy here. Even if you put rocks down the bottom of that, you're probably still going to have some undercutting there and end up with a fill failure such as this one. Pipe filled with sediment, you probably lost 40% of the volume capacity on that one. That looks like it may have just been bed load movement down the stream, may have been natural. Maybe not a whole lot you can do about that except for maintain the pipe, clean it out occasionally. On the left, functional ditch, heavy rainstorm, no ponding on the road. It looks like it's fairly low gradient. The water's not moving too fast, so that ditch is probably not going to cut and drop down from erosion. An example where there's not a ditch. It doesn't look like it's outsloped, so probably during a rain event, this whole area is going to be fairly well saturated. This is an example. This happens to be Red Creek Road again. The ditch is obviously not functioning because water's coming out of it. You need a culvert here to kick the water across. There happens to be a berm on this side. This drops down into a notch that you could stack a couple domestic cows in. It just drops like that. Runs right into Red Creek with no filtering. It's a situation where this should have been probably controlled further up the ditch and kicked across. The berm should have been knocked out. Delivering a lot of sediment to the road, and this whole ditch line here is cutting just like this. And you can see there's a lot of material being moved down into the stream. There's another example. This stream, or this ditch line, way too much water in it. And you can see how much it's cut down in. Further up, need cross-drain culverts or water bars or something to send the water across the road so you don't accumulate that much volume and that much energy. No functional ditch here. It looks like probably a skidder or something's ran back in here. It's ponded out in the road. Subgrade is saturated. You're going to get subgrade deflection. Basically, this is probably an active timber sale. I'm guessing they'll probably come in and clean it up, but they need to maintain that during the timber sale, or they're in danger of actually losing their road or the use of their road through here. Okay, fills. This would be fills over culverts, or it could be just the fills on a side cast road construction on the outside of the shoulder of your road. Let's see. You can assess. Obviously, if there's no fill, that's easy enough. Look and see, make sure the fill slope's functional and not eroding. Looking for the gullies coming off your fill slope that might extend down the hill, end up entering streams. Sometimes, if this is about ready to fail, if it's got too much water in it, you'll start seeing tension cracks along. A lot of times they'll be right where it separates from the native grade. But sometimes, if this is the running surface that's compacted enough, the tension cracks will be right on the edge of that. If you start seeing tension cracks, you've probably got a slope or a fill stability issue. If you can determine that the reason that you have tension cracks in it, most times it's water. Your ditch on the inside may not be deep enough. It may not be functioning. And a lot of times it's introducing the water causes the tension cracks. The other thing is that maybe you have a cross drain pipe, like you saw before, where it's eroding down below it. And it starts cutting the toe of the slope. If your pipe, a lot of times your pipe will stick out to here and the water plunges out and it starts eroding the toe of this slope, and pretty quick it cuts it back, and then this whole fill thing wants to start moving down the hill because the support's been removed. And so you just start, if you see a tension crack, you got to start looking. There's a reason why your fill is starting to move. You just need to try to identify what that is and correct it. Most time it has to do with water and getting the water off the road. And the other thing you'll see is sometimes from a landslide, you may have a landslide underneath your road that ends up taking part of that out, or you could have a landslide above it that fills in part of your road and narrows it. This is a situation where this is actually part of there's some land, it's part of it actually a big landslide. There's activity above it and below it, but you can see there was some fill put out here. This is a fill along the edge, just like I showed in the diagram over here, and this chunk took off and went down into the stream, obviously narrowing the road. An ATV can make it, but that's about it that can make it around at this time. Another example of a landslide. This is an example of a tension crack that says that piece is moving and that there's a reason for it. We need to find that out and fix it before we lose the road. But you can see that tension crack, it runs, and it's a pretty good size area. Whoever gets to fix this is going to be out some money. This slide's a little fuzzy, but when you're talking about the condition of the road, actually in Utah, brush isn't as much of a problem as it is in some other states. But you get the roadside brush in here, and a lot of times, your best running surface is this area here, and a lot of times you get out to the shoulder, it's kind of soft. Well, the brush just keeps forcing people out, and finally they get out and they start knocking your shoulder off. So either you want to close the road or you actually want to maintain it, keep people kind of on your primary running surface. This one here, the brush obviously is not the biggest problem. It's not being maintained at all. But in this particular case, I don't think that those rocks were placed there on purpose. Somebody built a road and then basically abandoned it without doing anything to it. Potholes. We see lots of those. Once again, if you can crown your road and maintain a crown, you can kind of keep the water off it. This one looks like the potholes may not be the biggest issue. It looks like there's a big failure here, maybe related to a pipe. This example of ruts, you can see water gets caught and just keeps on coming down the road. It's starting to cut a little bit here. It's ponded up here. Whenever you have standing water, your subgrade gets saturated, and it's pretty easy to get subgrade deflection. This is surface deflection, basically with the ruts. But that can compound, and that deflection can go down deep, and you can end up, basically ruining a road by deflecting the subgrade. In this case, it looks like it was a gravel road at one time, and they're in danger of losing their investment in that rock. Another example of a drainage issue, Red Creek Road. It's flat grade. There's no crown in this road at all. It's just flat across. And you get any kind of a depression, and you get this situation. You can see the difference between saturated and unsaturated. It doesn't take, the saturation the subgrade just starts disintegrating on you. It's a similar situation here. It's a wet area. If it's filled in, there may have actually been a culvert here at one time. I don't remember seeing any evidence that there was actually a culvert there. If there was, it filled in. This needs to have a catch basin dug out and then a pipe going across the road. This being a low spot, it needs a little bit of fill material over it, a little bit of rock. Be a good place for the geotextile. Some people call it filter cloth. Put a short segment so that this mud doesn't pump back up through your rock and contaminate it. What happens in a situation like that is you have I don't need to diagram it with the mud that you saw there. What happens is if you just throw some 3/4 minus over it and then drive over it, repeated trips, it starts pumping that mud up, and that mud will come right up and come over the top of your rock. The filter cloth, geotextile, is a fabric that allows water to go through, but not sediment. So you put that down and put your rock over it, and the fines can't pump up and contaminate your rock. Basically, it makes your surface rock worthless because you get a layer of mud over the top of it. And this filter cloth will keep that from happening. It is kind of expensive, but if you're rocking a road, rock's expensive. And on my own property in Oregon, I had a place where I had to put down about 200 feet of it going across the clay section. But there was just no way. It just swallow rock. Basically, the rock just disappears. But you put the textile down, it's like magic. The rock stays on top. It doesn't pump. It really can save you a lot of money. If you have a chronic problem, a place that's just a mud hole you can't get rid of, the geotextiles can really make a big difference. A rut. This is that road, flat graded, no crown. Somebody drove up it. The water decided, hey, this was a great route. This particular rut this road was graded like 2 days before this. There was a half-hour storm, and someone drove. In that half-hour storm, that little gully occurred. Another mud hole, just basically a situation where the water needs to be taken from one side of the road to the other with a pipe, and probably the road needs to be built up just a little bit here so that it's not a depression. And once again, put a little bit of crown on the road. It's a situation where you got a little bit of a berm on the outside, and you can see a pretty good rut coming down this road here. Berms, you see a lot on the outside, and they can really cause problems. There are situations I've seen where a road will go for a half mile with a berm and just keep accumulating water until finally it gets enough velocity to blow its way through the berm, and by then it may have cut down along the edge of your road several feet. This one here, you can see that there's quite a bit of cutting here, and it's mainly because the natural flow across and down the hill is being impeded by the berm there. A lot of graders, depending on the blade they have, they can cut through that, or you can send a little loader backhoe or a dozer or pretty much anything and just cut some notches in those berms. I don't like berms. I mean, they shouldn't be out there at all. But a lot of times once they're there, it's kind of expensive to get rid of them. So the easiest thing is just make plenty of reliefs through the berm so that the water can get off the road. This is one of Darren's slide about, this is I think the project where the guy designed the road from the cat, saw where he wanted to go and just got on it. You see a lot of this berm action, and this is on a brand new road, so obviously that berm's probably going to be there to stay. And it gets a little bit muddy, and so they make a pass to the blade, and they make another pass to the blade, and the berm gets higher, and the berm gets higher. And pretty quick, the road's the lowest thing around, and so it becomes a stream bed. As a slide I've shown before, just showing an example of identifying roads that are in valley bottom locations and knowing that you're fairly limited on your fixes to get rid of water if the road's the lowest point around. The other thing, you may have a ford. This is across Red Creek. If you have one, this one here, this road's a little bit steep and it's pure dirt, so you can imagine there's a fair amount of erosion coming right down into the stream. You've got a similar thing on this side. It's nice if you can take some of the grade out so it's not too steep, and then put some good clean open rock on both sides. A rolling dip, water bar, something to intercept water off the road surface itself and kick it off so it can filter before it actually reaches the stream. And then using open rock with no fines in it, with no dirt, to go across the stream here so you don't add any sediment when you dump that in there. Here's another example where you can see it's pretty steep coming off this side, and you can see that there is some cutting here, and you can see right where it's going. Diversion, an example where, for whatever reason, it may have been some landslide activity or something hit the stream, caused it to jump its channel. Could have been a beaver dam. Beaver notorious for causing new routes. You've got a stream, valley bottom road location. Water's pretty opportunistic. If it gets a chance to use your road, it will, and it may not give it up. Okay, after you kind of assessed, looked at your roads and looked at your needs, and you can kind of look at, okay, what are we going to do to fix some of these things? Stream crossing culverts. If you have fords or something, sometimes it's worthwhile to upgrade to a culvert. The culvert may or may not be the least maintenance. If it's a very big stream, you might want to look at going to a bridge. And your cross drain structures, this could be pipes. It could be culverts. You're basically looking at removing water from your ditches before you get so much volume and so much velocity that you cause ditch cutting or cause problems with your road surface. The road surface itself, the best thing to do is maintain a crown in it. If you have a very steep grade during the wet season, throw some water bars in it to kick the water off the surface so you don't rut down it. It's always nice if you can keep traffic off the road during the wet season, because the tire tracks generally become streams. The other thing is looking at the stream, the road stream connectivity, basically dumping your ditches into live streams and the problems that causes. The other thing would be wet weather hauling. In this intermountain area, the spring breakup would be equivalent to the wet weather hauling. Since Lou covered culverts, I'm not going to say a whole lot about them. This is a statistic from Oregon, and it looks basically it's looking at the causes of the failure, and it looks like the fact that they're too small really wasn't the primary reason that pipes failed. Most often it was floatable organic material. The biggest culprit in a lot of areas is, of course, beaver. And whether they build a dam at the inlet or whether they have a dam upstream that fails, either way they can put a lot of material into a pipe. And so obviously you want to be able to deal with the floatable organics. A lot of it, I think, is just probably having the proper size. The higher the water gets in your pipe, if things are floating, it concentrates them at a smaller cross section. So obviously here's your biggest cross section. I think one of the biggest benefits of the squash pipe is during normal flow where the water's down here, the diameter is wider on the squash pipe down here, and that probably has a lot to do with the plugging issues as well as having the miter on them. Having your pipe so the water hits the pipe straight on instead of at an angle, obviously it's a lot easier to jam stuff in if it's coming in at a skew on it. Some people may or may not want to do this. I don't know if I have the energy to go up and try to find anything that might float and clean it out so it doesn't plug my pipe. But trash racks, don't see too many of them in Utah. Basically, they look like a cattle guard across the top of the pipe so that big material can't enter the pipe. They work pretty well, but you have to maintain them as they themselves can become a dam. So if you have trash racks, you have to have a regular scheduled service to remove the debris from them. Good culvert installation. They've armored the outside a little bit. The pipe actually sticks out through the rock. Good armor on the pipe inlet there. Minimize erosion problems. Yeah, that's rock bigger than 6. I don't know if most people are going to be willing to import rock, but if you have rock handy, it's always good to kind of sort it out a little bit and kind of save it once you get the pipe installed. Save the bigger pieces to put around the outside, the biggest ones closest to the pipe. Example of a eroding situation here, probably too much energy at this particular pipe. One thing a person can do, if you have a draw that you're having trouble maintaining your pipe, you're getting stuff come down and plugging a lot, is deciding that if you have a plug pipe, where your water is going to go and controlling it so it doesn't decide on its own and end up cutting your road across. You can armor it, have a dip there, and send it across. I don't know in this country how much of a problem that is. I haven't seen where it's probably that chronic. But there are places where you may have one particular pipe that is always a maintenance issue that does plug up. There's a culvert in there somewhere. Obviously, it could be remnants of a beaver dam, beaver cuttings, or it could just be an accumulation of natural biomass, but obviously it's impeding the flow into the culvert. Saw this slide earlier, basically just once again demonstrating a culvert failure, a fill slope failure, improperly installed pipe, and the problems that it caused. This is a flume, half of a downspout. Looks like the fill material ends about here, so they got it to the end. You can see there's some organic material down there to help disperse it. Can be pretty helpful. And water bars, divert, should intercept the ditch water, take it off the road, basically like a cross-drain ditch relief culvert. Well, you probably figure that water doesn't flow uphill, so best to have the outlet lower than the inlet. And we talked about energy a little bit, but you need to get some dissipation on it. I talked about the ditch out not accelerating the water. You can dissipate it by having it splash on the rocks and spread it out somehow, or basically take the gradient out, and so it loses its energy before you disperse it. And then the distance between them, and this is something. If you haven't put water bars in your road before, you've got erosion problems, you want to correct it. How many do you put in? And there is no particular formula that you use. What I would suggest is you put some in. If you still get erosion between them, you need more. It's not very scientific, but or if you don't mind having them in, more is better. You probably can't have too many from a drainage standpoint. The road surface, this would be the running surface where the trucks or cars utilize the road. You want to keep it well maintained, and that primarily involves the drainage. You want a durable and stable running surface. A lot of areas they rock their roads for all weather. In Utah, many roads are not, so you kind of use them seasonally. But whatever surface you have, you want to maintain it so you can maintain a reasonable speed on it and not beat your rig up. We've seen this slide before once again, but it's just, as far as the maintenance go, if this keeps cutting, you can see right here where the trucks are running to here is not very far. It wouldn't take too much for this to start eating away your running surface. So in this case, the ditch can compromise your running surface. When the surface of the road breaks down or becomes rutted, you want to reshape it. Ruts obviously accumulate water, and as fast as you can get it spread back out again before the next rain, it'll help keep the road from disintegrating too bad. Once again, we don't use that much rock, but where you do have it, the best protection for your rock surface is a good functioning ditch. And then you can see a little bit of crown on this road. Between a crown and the ditch, that's the best way to protect your rock. It just keeps the water from accumulating and keeps your subgrade from pumping. Previous example we've seen, no ditch. The other thing is, when do you want to clean your ditch? If you've got grass in it, but it's passing water adequately, the grass will trap some of the sediment and help, keep the erosion down. So sometimes you just have to look at how it's functioning. If it's got grass in it and it's functioning, many times it's best to go ahead and leave it alone. Okay, on the road surface here, this is a water bar that's obviously put in to close the road. That does protect the road surface, but then again, I guess you're protecting something you're not using anymore. The main thing, I guess, would be that you're keeping the erosion down. An example shows that it's notched into the subgrade deeply enough that it's not going to, if somebody were to drive through this thing, it would probably still function. An example where they're using some organic material for energy dissipation and trap the sediment. Once again, obviously this is closed off. It may be a seasonal closure, or it could be they just don't need to use it for a while. Okay, the stream road connectivity. This basically, once again, is talking about having the water from your ditches or from your roads that ends up easily going into the streams. Okay, obviously it can be a delivery point for chronic fine sediment, which if it's a fish-bearing stream, obviously that's not a good thing. And then there's just the perception. If you have a road in proximity to a stream, people automatically assume that you're probably degrading the stream quality. Another example of ditch water, a lot of ditch water coming in. You can see that it's carrying a lot of suspended sediment and dumping it right in the stream and then headed down the pipe. A situation where somewhere up the ditch line that water needs to be taken off and deposited in an area where it can filter before it actually reaches a stream. Okay, this road obviously is right in the valley bottom. Mid-slopes roads obviously can still deliver sediment, but at least you don't have the proximity issue. You have more of a chance of dispersing the water before it actually reaches a stream from a ditch on a mid-slope road versus a valley bottom road. Once again, the perception of people see a road that's down low, they assume, many times rightfully, but not always so, that it's causing sediment load problems. If you have a stream adjacent to a road and you're delivering sediment to the stream, you can armor the road surface, put rock on it, a coarser rock, to help trap, and you may want to use a geotextile or something so you don't pump any mud on the surface so that it can run off into the stream or the ditch and then the stream. And then we've talked about kicking the water out of the ditches in a place where it's not entering streams directly or where it's far enough from a stream that it can filter the water before it reaches it. And maintain the surface shape. Once again, this would be the crown primarily, keeping the road surface in a way that it won't collect and carry water and cause surface rutting. And if you have the option, move the road to a location where it's not going to cause many problems. Slide shown before, once again, it's just kicking the water off and allowing it to disperse before it reaches the stream. Wet weather hauling or breakup, I guess, would be similar. The situation where you're getting the pumping action here, either this road doesn't have enough rock on it, or it may at this point have no rock on it, but it probably has had enough moisture in the subgrade that you're seeing the pumping action here. A case where a geotextile and a lift of rock over it might fix the problem. This is a situation where the road's pumping mud through, and you can see it in the water there. That's primarily sediment from a logging road that's going down that waterway there. Inspect your roads during wet weather use. Avoid them during wet weather. Don't use them during wet weather if you can, and obviously avoiding the spring breakup. You start seeing that layer of mud. You're pumping subgrade up through your rock, and your subgrade's your foundation for the road. You start failing the subgrade, you can have a total road failure. So you start to see surface deflection. It's time to take some sort of action. If nothing else, just shut off the hauling. And of course, the problem is you saw on the previous slide where the road was pumping and the runoff from that road was ended up in the streams. And then when you saw where the trucks were hauling, the road surface was breaking up and you were getting surface deflection. This will be the crown road, allowing for good drainage. The first initial step you'll see is on a rock road. You're getting the ruts forming, you're getting a little bit of subgrade deflection, and then you're toast when you get to that point. And a lot of this, it may well be that this ditch is not carrying water off well enough, and so you're saturating this whole grade. I'm not sure if that was the intended function of the diagram or not, but a lot of times if you'll see a full ditch, you'll see ruts in the road adjacent to it. And that means generally because your subgrade is saturated. This is where we're headed after this session, up across the road here. We're not going to get a chance for everybody to get out and look at everything. We're going to one destination. On the way through, you'll see we head up this through cut. And obviously in a through cut, you have no place to kick water off. Once you get from the top of the cut to the bottom, you just have to deal with it. And one thing is you can put open rock. You can armor, say, the ditch line with rock so that it can't cut, or you can actually put some drain rock in it and put a drain pipe underneath it. On this side, I think maybe my next slide, this is the pipe that was on the right side of that thing. And it did a good job of protecting the road, but once it got off the road, there's a pretty good plunge, and you can see all the erosion right here that's undercutting. And sooner or later, it's going to affect the road because of the cutting action there. This is too much water going too far down a ditch line. You can see that it's cutting, and this is probably happens seasonally. It's best to try to either do some blowouts, kick them off, or put some pipes in, kick them across the road, depending on the situation. But basically, anytime you see this, you've got a problem that you can probably correct. And whether you see it actually on your running surface or in the ditch, either way, you're going to have maintenance problems if you don't do something to control the water. Situation where you got a little bit of a berm on the outside of the road, and you can see instead of allowing the water to go off the road, it's trapped, it's containing it, and it's got enough energy there to cut that surface. So that means that's probably an annual event in that case to go in there and regroom your road. Ditch line carrying too much water and cutting. Another situation where you probably need to, with pipes or water bars somewhere up the hill, get rid of some of that volume of water. This is a culvert here. You can see that it wasn't long enough to stick out, and you can see, it looks like it's been, someone's been in there and cleaned it out, but that's probably, since the pipe's too short, probably, once again, might be a seasonal activity that could be avoided if the pipe was longer. This is the outlet side, and you can see that it's pretty well buried. There's enough debris down in here that's actually up to the top of the pipe level and causing it to back up. And that's just a sediment deposit that came through a pipe. This is one we'll stop at, so I don't have to say too much about it, except for you can see a lot of this material is deposited here. It's actually from this cutting action, and this goes feeds into, I think, a 30-inch pipe right there. This is the 30-inch pipe. This sediment, once again, isn't from the stream itself. It's just from adjacent ditch water being dumped into it. At this end, it's about 40% filled up. At the other end, it looks like it's about 60% filled up. You're seeing some rutting action in the road here. This is a spot where you see standing water in the ditch. This actually is a situation where there's a structure down below, so if you took a pipe across, you may end up putting your structure at risk. But you may want to consider cutting the ditch a little bit deeper in this area to get this to flow out. So this standing water means this subgrade is saturated, and you can see quite a difference from where there's no standing water in the surface, running surface, versus where there's standing water in the running surface. This just, to me, it'd be a skid trail. In this particular case, is some kind of a trail on the base here, and a pretty deep rut in it. Good place for a water bar. Kick the water off that so it doesn't continue to rut down it. Another pipe, looking at the road, water's coming down the edge of the road and then coming off right into your drainage, and you can see that it's cutting, and all this material, and that material is depositing downhill, down below, and filling up the pipe. And this is the same pipe looking at the road. You can see this coming off the road surface, coming right down in and basically filling up the pipe. And this is a rock road, so there's also an investment in the rock that's actually being lost down into that gully, as well as filling the pipe up. And like the pipe that had the concrete head wall on, that's not an easy pipe to replace, so obviously it would be good in that situation to divert that ditch water somewhere so it doesn't fill it up.